Our next speaker is Rafael STAHL from the Technical University of Munich in Germany, and he will be talking to us about utilizing static code generation in TinyML. Go ahead and take over, Rafael.
Thank you very much for the introduction. And I will present how we utilized static code generation to optimize the deployment of models for TinyML. So the machine learning on microcontrollers enables these advanced low-power applications using sensors of video and audio, radar, chemical sensors. However, running on microcontrollers is putting very hard constraints on these models in terms of runtime and memory usage. And we have been experimenting with the frameworks TensorFlow Lite for microcontrollers and Micro TVM, and have experienced quite large overheads in these frameworks for such tiny microcontrollers. So this work targets the deployment for these two frameworks to optimize further. So the approach, looking at these two frameworks, we see that the machine learning model is put through some model compiler, which produces a compiled ML model, which is then moved onto the target device, and using a runtime of the framework is then processed and loaded dynamically to extract the control flow information and static data of the model. So instead, our approach takes this compiled ML model from the framework, puts it through a static code generator that extracts this control flow information and parameters and puts them, generates them as code, in this case C or C++ code, that is directly deployable for the target device and therefore no longer dependent on the framework runtime. It can be directly used from your application. The results we have for these are evaluated on the TinyMLPerf models, and I've added also a custom CFAR10 model that we have developed, and they are run on or compiled for RISC-V and simulated on our open source ETIS simulator. When first looking at the runtime results, we see that for TensorFlow Lite, the runtime overhead was very low, so there are minimal savings in this case. However, for Micro TVM, we saw quite significant, and especially for smaller models, up to 8x improvements in runtime by getting rid of parsing of the model. When moving to RAM usage, so working memory, we saw also for TensorFlow Lite quite significant improvements. Note that this is the logarithmic scale, and especially for Micro TVM, the runtime had a very large overhead because they were depending on large libraries for parsing. And finally, for the read-only memory, we have seen in both frameworks quite significant savings by deploying these static code generation approaches. Both of our tools are available open source, as seen here. And that is from my side. Thank you very much.
Thank you, Rafael.
I want to thank our sponsors that made this event possible. So the premier sponsors, Newton, working on automated TinyML. If you were there a few days ago, they had a keynote explaining what they're doing. Executive sponsors are ARM, Edge Impulse as well, and Qualcomm, Sentient. And then our platinum sponsors, we have Infineon and Reality AI. Gold sponsors are Latent AI, SensiML, and our silver sponsors are EMEA, Greenwaves, HOTG, Imagimop, GISO, Seed, and ST. And with that, I thank you very much for staying on till the very last end, the last day of the last session of the last day. And with that, I think we can close the forum for this year. Thank you, everybody, for contributing. Thank you, Andreas, for also moderating this session.